Hello everyone, I'm Paul and today we're solving problem 36, valid Sudoku. This is medium, and next I will show you my thought process and efficient solution. We are given a 9x9 Sudoku board such as this one, and we just need to return true if the board is valid or false if it's not. If this is the first time you see a Sudoku board, this is how this works. Each row must contain the digits from 1 to 9 without repetition. We need the same for columns and we need the same for every 3x3 sub box. So for example, if here we have a 3, given that in the same column we have another 3, we just return false. If we have a 5 here, for example, given that here we have another 5, we also return false. And if we have a 9 here, for example, given that here in the same box we have another 9, we also return false. And if we meet all the conditions, such as in this case, we just return true. So my first intuition here is to try to simplify this problem. Let's say we only want to meet the first condition, meaning each row must contain digits from 1 to 9 without repetition. How can we solve this if we only think about this first condition? Well, we can have a map. Here we can store every row as a key. So here we have row 0, 1, 2, 3, and so on. So these are the keys in our map. Here we have 0, 1, 2, and so on. And each of these keys will have an empty set initially. And let's say we are iterating this row 0. And let's say we have a 3 here. First we add 5, then we add 3, then we add 7. And then when we reach this point, we check if we have this in our set. We have a 3 here, we just return false. So in this case, we will return false. Now if we only have one 3, we end at 7 and we continue with the next rows and we repeat exactly the same process. If we reach the end of the rows and we never return false, we can just return true. Now if we can use this approach for rows, we can use exactly the same approach for columns. We can have a map where each key corresponds to one column and each key has an empty set as a value, and we are storing every value in each column in the corresponding key, and we repeat exactly the same process. Now the tricky part here is how do we handle boxes? Well, we know that the size of the grid is always 9 times 9 and this is fixed. So let's say we're standing here and we want to get the box we are standing at. Here we are at row 1 and column 1, 2, 3, 4, 5. So we can take the row number 1 divided by 3 and we need to round down this value, and the result for this is 0. And we do the same for the column. We take 5 divided by 3 and this is 1. Remember, we need to round down this value. What this means is we are standing in the box at row 0 if we consider this as the row 0, this as the row 1, and this as the row 2, and column 1. Remember, in terms of boxes, this is column 0, this is column 1, this is column 2. So we are dividing everything by 3 because the size of the grid is fixed at 9 times 9, and this means we will always have 3 boxes. We always have 3 boxes in terms of rows and in terms of columns. Okay, so we need to divide everything by 3. And now we know that number 5 corresponds to the box 0, 1. And this is a unique key. So now we can implement our approach here. We can have a map where each key corresponds to the coordinate for each box, and each key has an empty set, and here we are storing every value in each box. And if we find a repeated value, we just return false. And if we reach the end of all of this and we try rows, columns, and boxes and we never return false, we just return true. So this is basically the entire approach. Now let's go with the code and hopefully you will get the idea. We'll have a dictionary for rows. This is a default dictionary, and we will set a default value of an empty set for every key. So here we use the word set. We are doing the same for columns and the same for boxes. And now we can iterate the grid. Remember, the size is fixed at 9 times 9, so for I in range 9, for Shay in range 9. The current value is board I Shay, and we can have dots here, and they represent empty spaces. So if we find the dot, we just continue. Else, if we have a number, we need to check if we have already seen this number or not. So if we have the current number in the current row, or we have the number in the current column, columns at J, or if we have the number in the current box, boxes, remember here we need to use our special key. We have a tuple with I divided by 3, J divided by 3. So if any of this is true, we just return false. Else, we need to add the current number to rows. So rows I dot add x. We need to add this to columns. Columns J dot add x, and we do the same for boxes. Here we need to use our key I divided by 3, J divided by 3, and we add the current number. And after all of this, if we end this loop and we never return false, we can just return true, meaning this is a valid Sudoku, and this is return. Okay, so this is it for the code. Now let's submit this and see if it works. This works and it's very efficient. Time complexity here is big O of 1 technically, because the grid has always the same size, 9 times 9, and the space complexity is the same. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.